So now I want to talk momentum part 2, and I want to talk about this thing called impulse. An impulse, all that means is a change in momentum. So what do you use as to represent a change? We use the symbol delta. So delta P, or change in momentum, and we're going to have delta P. One way to find the change in momentum is just to take the final momentum that we get, or PF, and subtract it from the initial momentum we started with. So if an object starts with 20 kilogram meters per second, and then it goes to 10 kilogram meters per second, well, then what happened? Well, we had a change of negative 10 kilogram meters per second, and that's going to be our delta P. So another equation that we have dealing with impulse is that the change in momentum equals the force that it took to do something times the time. So this is helpful because then we can begin to isolate things. So if I have a 10 kilogram meter per second change in momentum, and it took 1 second, then what does that mean my force was? So I'm just going to take delta P divided by my time, and that's going to give me my force. So I have negative 10 kilogram meters per second divided by 1 second, and that's going to give me 10 newtons. And negative 10 newtons too, because and that just means that it's acting in the negative direction. So that's kind of how we can work with these. We're going to use this equation and this equation, these two equations, to get answers for that. But I also want to look at some graphs here. So first, the graph, I'm going to have a force times time graph. And if I take force, which is kilogram meters per second, kilogram meters per second squared, my bad. And how do we know the unit of force? So it's kilogram meters per second squared. But remember that force equals mass times acceleration. And so mass is measured in kilograms, and acceleration is measured in meters per second. So I have kilogram meters per second and time. So if I have a graph of this, and I take the area of the graph, if I take the area, I'm going to multiply them together. And so I'm going to have kilogram meters per second squared times seconds. So seconds cancel out. And then I'm going to get kilogram meters per second. And what is this? This is the unit of delta P. And so that's how this equation is derived. But when we see this on a graph of force times time, then we can see, okay, a physical representation of what that means.